Hello, I'm Maddie Bright, and I'm here today to talk about privacy in cloud computing. First, let's establish the basics. What is cloud computing? And cloud computing is when it is your information and someone else's computer. And this differs from traditional computing, where the person whose data it is owns the computer. For example, I am using my laptop, and if I edit something on normal old Microsoft Word, that's not cloud computing, because I have my copy of the application customized to my liking. It's hosted on my computer with my information. However, it becomes cloud computing if, say, I go into a web browser and use Office's 365 online Microsoft Word, because that is not my application, and I'm putting my data into that Word document that's ultimately stored on someone else's computer and just associated with my account. And as you can see in the diagram to the right, cloud computing varies widely in complexity and the type of services provided. It can be anything as customizable as choosing all the specs for a virtual machine that you're going to treat like a server you own, to having an app that you can just customize for your organization and that's hosted by the cloud service provider and not yourself. For example, every organization that wants to use Slack does not have to host an instance of Slack on their organization's own servers. They can just use the Slack app hosted on the Slack servers with customizations for their organization. So that's just a general idea. And now here are the different types of cloud. A public cloud is a cloud that anyone can sign up for and access. For example, take Google Cloud Platform or Amazon Web Services. Anyone can create an account on these sites, and anyone can start using their services. A private cloud is a cloud hosted for an organization. For example, I worked at an organization which hosted a payroll server in a closet in the building. And this could technically count as private cloud because there was one copy hosted in one location, but we all interacted with it. We didn't each have our own copy of the application on our individual computers. And we all also didn't store the payroll data that we each submitted on our own computers. It was all stored in that other location. There's also the community cloud, which is when a cloud is opened up to a group of organizations that need to use it. An example of this that I heard of recently is the VI-class system used in Canada by the Royal Canadian Mounted Police. VI-class is the Violent Crimes Linkage and Analysis System, which is a database of crimes and offenders that can be used to find patterns. For example, if there's an unsolved murder, maybe it can be correlated with the pattern of a serial killer operating during that time period. And that's a community cloud, because the different pieces of the RCMP and the Canadian Police Departments can access that database and can add to it and can perform analysis operations on it. But they don't each have their own copy. They're not each segregated apart from each other. And only this group of organizations is allowed to participate in it. And now there's a final type of cloud called the hybrid cloud. And this is a new development that's actually pretty cool. It allows you to connect your existing private cloud to public cloud services. For example, you can extend an existing firewall across Amazon Web Services machines in your virtual private cloud. This is pretty handy if, say, you have a variable strain on your computers. Maybe most of the time your private cloud can handle the load just fine. But if your private cloud has too much of a load on it, you can move some work into the AWS cloud. And for all intents and purposes, to your network, it'll look like you're still operating out of the address space of the private cloud. So I have used this before because I was unable to access applications while using a public cloud machine because these applications were firewalled off. I needed to access them. So when we switched to using a hybrid cloud, now all these AWS machines that I could control through AWS looked like they belonged to my other workplace, and they were allowed to use this application that was firewalled off. So the cloud is actually pretty freaking cool. It's cost efficient because you only pay for what you use, which makes it superior to regular computers. Say you don't quite know what you're doing and you buy a computer that's way more powerful than you need. You've probably overspent. And once you've got everything set up, you probably can't afford to return it. The cloud is also reliable. Because it is distributed, you can pick and choose the way you want to back up your data or restore your services if, for example, the virtual machines you are using have gone down. For example, in the event of a terrorist attack, other data centers can resume the operations of a damaged data center. Or if one set of computers in a center has to go down for service, their workloads can be shifted to other computers. Unlike, say, a personal computer, if I need to take my computer in or my server in for service, I can't use it during that time period unless I have a backup. And if my computer and the backup go down at the same time, well, I'm just out of luck. I don't have the resources to have that kind of elasticity on my own that give in my service availability. Similarly, you're also paying the cloud provider to manage your hardware and software, which means that it's one less thing you have to control. For smaller organizations who may not have the IT resources to granularly manage everything, having that abstracted away can leave them to focus on more important aspects of the business. Similarly, the cloud is available worldwide. No longer do I have to be in the same building or connected to a local area network. I can log into AWS from anywhere in the world or on a VPN. It's pretty cool. It also means that you no longer all have to work in the same building, which makes it easier for businesses to expand. Now, the point about security actually goes back to the similar point about hardware and software management. You configure the cloud yourself, but the options you're given are options that the cloud provider has already worked on and tested and knows will be useful. Which means, again, that's one less thing you have to think about. Finally, and surprisingly, especially for me, I didn't think about this before working on this PowerPoint, is that the cloud is actually more energy efficient. And I'm surprised I didn't think of it before, but it actually makes a lot of sense. When you're running these resources out of a centralized location, you don't have that kind of pool all across the power grid, for example. You can also, when you're using virtual machines, conserve the amount of resources needed to produce computers and servers. Since virtual machines aren't physical, and you can have multiple of them stored on the same physical host, the energy that might have gone into producing like 5 different computers, the heavy metals and precious metals needed to produce electronics, those are conserved. And I actually think that's pretty neat. That to me is a really cool part of cloud computing. However, it would be unfair of me and sound like an advertisement if I only talked about the good things. There are huge problems with cloud computing as well. This is due to the do it and ask for forgiveness later nature of technology, which has brought us some wonderful things. However, it also means that as a consumer, you are the one who pays the price if an operation goes wrong in the cloud. You're responsible for protecting the data you put into the cloud. And if a company puts data into the cloud about you and it's breached, you are ultimately the one that's probably going to suffer the most, should that data be used. There aren't regulations that apply to cloud computing as an industry as a whole and what they can do with your data. Similarly for standards, again, that's all on the person who's implementing the cloud solution for their own needs. Similarly, there are also always novel developments occurring in the way these cloud services are used, in the type of cloud services deployed. For example, I recently listened to the podcast Bear Brook, and I thought it was amazing. However, in episode 7, Chameleon, in which the case of Terry Rasmussen is discussed, it reveals that the genetic genealogy used to identify the serial killer and his daughter actually had a lot of other issues. For example, these genetic genealogy studies started using public access genetic databases, for example 23andMe, that anyone could upload their data to. And people who go to use these databases aren't looking to be involved in criminal investigations. But these are in the cloud. Anyone can access them. They're a centralized application. Everyone's putting their data in, and it's being searched through. After genetic genealogy was used to find the Golden State Killer, and in the Terry Rasmussen case, a lot of these cloud databases that store genetic information had to start changing their terms of service to prohibit police access for these kinds of cases, because people weren't signing up for these purposes, and it was really uncomfortable for people to become involved in these really sensitive circumstances. And it was really disturbing in another way. You share genes with your relatives. That's how genetic genealogy was able to trace back from distant relatives to a common ancestor and figure out who Lisa, the girl in the podcast who worked with police to identify herself after having been abandoned at a trailer park with a false identity. They started at her fifth cousins and traced back to a common ancestor. To do this was only possible because of the gene similarities between the distant relatives and the common ancestor. And that means even if I don't put my genetic data into a database like this, someone else could use a distant relative's, me, or even a close relative. My grandfather and my aunt both have done the 23andMe tests to trace back and eventually find me. This would be really uncomfortable, and I wouldn't want this data to be used. I'm sure most people wouldn't want this data to be used to find ugly family secrets. I mean, if discovering my grandfather was British caused my grandmother to joke about how he should only be drinking tea, and for her to be disappointed because she thought he was German like she was, I mean, I can't imagine the destruction that would be caused to just any family who would discover horrible pieces of information, like being related to a serial killer. So, legislation can't keep up with all these novel developments, nor necessarily can the terms of service. The data used in the cloud databases and in cloud services, what will happen next always has to be on your mind, which is less of a concern if it's your local computer where you have complete control. So let's get into a few specific examples of privacy concerns in the cloud that, again, while they would exist on your local computer as well, they're more of a concern because the cloud is a black box. You don't know what's going on inside of it, but you can use it anyway. Actually, before I do that, one final thing. The cloud also suffers from a lack of public trust. And I did mention this when I was discussing the episode of Bear Brook and the Terry Rasmussen case, where the cloud was used in a way that wasn't expected, and it became really unsettling. Despite being good for the victims and their families, these people, they don't want their families to be associated with this serial killer forever. And to be fair, given the level of technological literacy that we are able to absorb and understand without specialized training, like getting a computer science degree, it's hard for people to understand every single nuance that goes into the cloud, and I doubt many professional computer scientists would be able to adequately assess every single nuance of cloud computing as well. There are different security concerns, especially among the public. There are concerns about accessibility of information and outages. I mean, if you lose your private key that was generated by the cloud, you're pretty much out of luck for accessing whatever that key was protecting. And even people who understand the cloud, as you see in the picture, don't always trust it. There's too many unknowns and too much of a risk. As I said, cloud computing is a black box. This term is used in computer science to discuss something that you can use, but you don't know how it works. So, not knowing what goes on behind the scenes makes a lot of people uncomfortable, especially when it's their sensitive data and sensitive information and even legal compliance that's on the line. Okay, so after that brief digression, I will now go into the issues which pertain to cloud computing. And the one that comes to mind almost immediately for me is encryption. And I realize that the first bullet point says transit and transmission. It should be in transit and at rest. So when you are working with data, a lot of the times it's either stored or you're sending it somewhere. When data is currently being just stored, it's considered at rest. When data is being sent somewhere, that's called transmission. And in both of those circumstances, your data can be encrypted, which for modern purposes means that complex calculations are applied to that data that can be undone with a specific other number that corresponds to the number used in one of the numbers used in the calculation. However, those two numbers, and due to the complexity of the calculation, you can't derive one from the other, which is really good for security and really handy. However, data is only so useful if you can send it around and just have it sit places. Sometimes you need to operate on it, especially, for example, in a database, where you would want to actually analyze and manipulate data sets. To do that, right now, you have to decrypt the data first. And then again, this goes back to what I discussed earlier. The numbers that produce those calculations, we colloquially refer to them as keys. And the person that owns and generates the keys has complete control over them. And sometimes that's the cloud provider. AWS will automatically generate you some nice new flashy keys for your virtual machine and not let you log in with a password the first time. If AWS's key generation algorithm, for example, was flawed and it was possible to derive the private key from the public key, or the public key from the private key, that's game over. If you have both the public and private keys, you can access basically whatever you want that uses that particular set of keys. And you can send messages that make it look like they were signed legitimately, but are really forged. Similarly, what if copies of the keys are made and you don't know? Now this sounds a little bit like a conspiracy theory, but given the fact that the cloud is a black box, you don't know what's going on under the hood with the key generation or how the keys are stored and manipulated. I would be uncomfortable with the idea that copies of my private keys were being stored and that I didn't have control over whether or not they were kept or deleted. Or even if they were used without my knowledge by, say, an insider threat, which I'll cover later. An example of this is what happened with Capital One in 2019, where personal information, PII, was stored in AWS S3 buckets, which are essentially virtual storage units. I'm going to call them that. And this was accomplished with something called a server-side request forgery. So, in a normal request, say I am the client. I go to a grocery store and I purchase something. I hand over the item I want to purchase, but I also hand over my money and say my ID too. And the cashier, who is at the server, looks at the information that I have provided and goes, okay, you can purchase this, and lets me walk off with whatever I wanted to purchase. And I've accomplished what I came to accomplish. In a server-side request forgery, say I'm the client again, but instead of handing over legitimate money and a legitimate ID, I hand over counterfeit money or a counterfeit ID. However, let's say that the server, the cashier, doesn't catch this while processing my transaction. I am allowed to walk off with something that I should not have been permitted to have. And that's essentially what happened in the Capital One case. To make a long story short, the same credentials could access the private keys for those S3 buckets, but also the contents of the S3 buckets themselves. While it seems like it might just be a common sense way to work this, it also means that an attacker would only need one account to wreak this kind of havoc that happened. And Capital One would have been a great target for a breach due to the amount of sheer financial data it holds on consumers, which cybercriminals would find very valuable. So you can understand why, especially given the amount of role customization options and identity permissions, customization options that AWS offers, why wouldn't you use that? And this is a case where you would be impacted by somebody else's use of the cloud, even without using the cloud yourself, because you can't control how Capital One stores your data, especially if you have to use them for some reason. You just have to accept that Capital One will manage the risk appropriately, which, as you see in this case, they did not necessarily do that. Now, about that insider threat I mentioned before. And this is where you start getting into your spy movie stuff. An insider threat is accidental or intentional damage caused by an employee and can be simply a miscommunication. And these account for around 30% of breaches. And this happened to Cisco. An employee resigned, and after resigning, using the information that they had as an employee of Cisco, was able to damage the AWS virtual machines that were important for Cisco's WebEx product, which I'm pretty sure is used for hosting virtual meetings. And this caused massive damage, deleted hundreds of virtual machines, and impacted 16,000 accounts. And of course, it's a criminal matter. This would, to use an old-fashioned example, if you fired someone and they came back in with a baseball bat and smashed all your local computers, that's kind of equivalent to what happened here. And what makes this an insider threat rather than sneaky hacker movie thing is the fact that the employee, as a virtue of having worked for Cisco, was able to carry out this attack. They were an employee, they had that insider knowledge. In a way, the Capital One breach is also a case of insider threat, but I didn't want to use that one for every single example because there's so many interesting cases out there. But, that one was just a mistake. It seemed practical enough on the surface to allow the same identity in AWS to have access to both the key generation and the S3 buckets and the ability to decrypt the S3 buckets. Honestly, I probably would have set it up the same way without thinking about it too much. But because that vulnerability wasn't realized, because that wasn't something that crossed people's minds, it could also be considered an insider threat. It was a mistake by an employee or a group of employees that allowed the breach to occur. Another common cloud threat is the fact that a misconfiguration might happen. And you're probably rolling your eyes and being like, well, everyone can misconfigure something. Everyone makes mistakes. The difference is, again, the black box nature of the cloud. While you, yes, control your own misconfiguration mistakes, mistakes on the part of the cloud provider may not be realized or fixed immediately, especially if one is expecting security by default on cloud resources. And a lot of these go unnoticed. For example, in one of the sources I cited, I read an analysis of the results of a study in which companies were asked how many misconfigurations they caught and resumed every month. Companies responded in the mid-30s. When the people performing the survey actually looked at the systems, however, they often found that upwards of 3,500 misconfigurations were present in any given month. So only finding and noticing and resolving 30-something of those. That is a huge knowledge gap. That is a huge possible exploit. That is a huge risk. And you probably wouldn't be comfortable having your data handled in such a way that something as simple as forgetting to click a checkbox can make it totally vulnerable. But unfortunately, that's some of the reality of cloud computing. Sometimes having something be ridiculously easy to do, for example, just ticking off all the checkboxes on the virtual machine you want, isn't necessarily the best way to make sure you can do it. I have been guilty of this myself. I was once spending hours trying to figure out why doesn't my virtual machine connect to the internet? Oh, I forgot to actually enable it being connected to the internet. Whoops. And again, it's so simple that everyday mistakes, well, mine may have been innocent. I could have made one or more that were not innocent and never have known. So a case study here is CenturyLink and their third-party MongoDB databases, which were, although these records were never accessed, it's still considered a leak because they could have been accessed due to the results of a misconfiguration. And this happens all the time. In this image, this might not be the CenturyLink database, but this is a MongoDB database that has been compromised, probably as a result of a misconfiguration. And the person exfiltrated all of the data and is like, well, now you gotta pay to have your database back. And I don't trust an attacker with my information at all, because who knows if they're going to keep a copy, who knows if they're going to sell the data, who knows if they're not going to tamper with it before handing it back. To reference an extremely old meme, it's gonna date the kind of people I hang out with. MongoDB is not web scale, and MongoDB is not secure by default. We've exploited similar vulnerabilities on Drexel's Capture the Flag team. We always get super excited when we find them because they're just so easy and such low-hanging fruit. But unless you're really, really double-checking, triple-checking everything against the documentation and the best practices, you're not going to catch these all the time. And they're really easy for attackers to find. Now we get into a question that is pretty important for cloud computing as a whole, and one of the things that I think defines how the nature of cloud computing is fundamentally different from the nature of not cloud computing. Who owns the data and who owns the computer? This is going to define the question of responsibility. If you face a breach, who is responsible and whose response? Who is supposed to be responding? Can your cloud provider say if they think you're holding illegal data, lock you out of your information, or just turn it over to the police without gaining a search warrant or notifying you? And right now, these access and security issues are primarily the owner's responsibility, the owner of the data, not necessarily the cloud. So if you're locked out of your own data and you can't figure out a way to get rid of it, it might just stay there. You might just have to keep paying for cloud resources if you're not sure of the integrity of the deletion and its sensitive information. Similarly, you want to control cloud service provider access. As I talked about, insider threats. Would you want a cloud provider employee acting against you, attempting to cause mayhem and damaging a bunch of different companies and individuals in the process? Yeah, these places are pretty secure, generally. But people can be determined, people can work together, and people who work at these places would have insider knowledge to cause harm and damage. And is that a risk that I would be willing to take? I've taken it in the past. And nothing bad has ever happened to me, but that's also a human bias. It's like the same thing that keeps people eating raw cookie dough. Oh yeah, I've eaten raw eggs before a ton. It's never hurt me, so I can continue doing it. Well, what if the next raw egg you eat gives you salmonella or something? Like, is that a risk you're willing to continue to take? And again, that's an individual question. Personally, I don't really want to eat raw eggs because I like staying healthy. But for someone, if that cookie dough, the taste of that cookie dough is totally worth it, I can see why they would continue to eat it. You also have to, if you're the owner of the data, know where your data is going. If your data is stored in other countries or data centers across the world, it has to follow all the laws of the countries in which it's stored. And it has to follow the transmission laws regarding moving it around in and out of those countries. I mean, this is something we see today a lot with GDPR. You'll be going on social media and someone will post a link to a news site, and it'll be an American news site, and all of the European readers will start asking, hey, can I get the text of this article? I can't access it in the UK. I can't access it in France. And people will give them the text of the article because due to the GDPR regulations, they can't actually access that content. Those sites are set up in ways that would violate their privacy rights as protected by the GDPR. And finally, the question of ownership is a question of transparency. Cloud computing is a black box, as I've said, and I hope that you all have been making the same assumption I did, that this black box is an opaque black box. You cannot see through it, you cannot see into it, you cannot shine a light at it and turn your head and hope to peer through the side. You are, under most cases of cloud computing, assumed to own your own data. You are controlling that data as much as you possibly can. But you still can't 100% see into the systems that are moving it around into the way the data center is working with it and manipulating it and storing it and virtualizing it. You just have to trust. And I mean, this is your data. You're going to want to protect it to the best of your ability. And you for sure wouldn't want to get into a situation where, like, you trust your luggage to an airline company. When it comes back, it's damaged or there's stuff gone. You would want your airline to be transparent about the way in which they are going to handle your luggage and how they're going to respond to this. And it would be a breach of your privacy too. You want to make sure that, again, the cloud provider, even though they're simply providing a service, isn't negligent. And right now, we actually have some technologies that can help protect cloud users and the data stored in the cloud. And this is just a very basic example of a technology that our computers are probably doing, of a computation that our computers are probably doing every single day without us realizing it, which is calculating a checksum. When you get data, say from an internet download, an arithmetic sum is calculated. And then a separate piece of information that, say, came with the download called the checksum is added to that sum calculated from the data. And if you get 0 out of that computation, you're cool. The data was not transferred with or changed during transmission. And it's a very basic protection technology. But it's extremely important, again, in that black box to make sure that the data that is your responsibility to protect, but you have no control over the implementations of the systems with which it is being moved or manipulated, well, you gotta have some way to make sure that everything's still a-okay inside that black box. And so after maneuvering or manipulating data, just checking to make sure it still maintains its integrity is a way to help protect the people who use the cloud or whose data is being moved about the cloud. As I mentioned during class one day, I saw an account of someone on Reddit who said that somehow, somewhere, a brain aneurysm got added to their medical history and they can't figure out where the mistake came from and they also can't remove it. So every doctor they see keeps trying to send them to the emergency room so that they can have emergency surgery on this impendingly deadly aneurysm. This is an example of data not having been verified for integrity. And we actually could have some pretty concerning impacts on someone else's life. Another technology that, while not necessarily useful yet, will probably be useful in the future, is homomorphic encryption, which basically allows you to manipulate data while it's still encrypted. If you'll remember back earlier in this presentation, I talked about how data could be encrypted at rest and during transmission, but that if you wanted to manipulate it, you had to decrypt it. And that the cloud computing providers generally owned their own mechanisms for managing and generating the keys used to encrypt and decrypt this information. Well, with homomorphic encryption, you don't have to worry about the decryption during manipulation. And the results that come out of the operations remain encrypted, which would allow the storage provider a lot more control. If you're storing data in the cloud, no longer do you also need to store the associated decryption key if homomorphic operations can be performed on that data, which, again, it's a form of giving you more control over your data, and one less piece of information that the cloud service provider has that could be potentially mismanaged or misused. However, right now this technology doesn't work because it is ridiculously inefficient on the size of the data sets that we currently would need this kind of encryption for, or that are stored in the cloud. My dinky little test databases that I've built for my classes are nowhere near the size or complexity or linked nearly as much as the databases that would be stored in the cloud. For example, even a small business's customer database is probably larger than any database that I have personally created and manipulated. And if it's not going to work for anything but the tiniest of datasets, it's kind of impractical to offer as a service. Finally, we get to the good part. The fact that although the cloud is a black box, there are a few things that the National Institute of Standards and Technology, under the Department of Commerce, can actually recommend you do. The fact that these problems have been analyzed over and over by experts and are recognized is, it's not a comfort. Comfort is the wrong word. But it's good that these kinds of thoughts and discussions have happened elsewhere. And NIST recommends that policies exist for everything that you do involving cloud computing, and that you're operating in legal green areas. For example, I mentioned before that data could be transmitted or stored across international and state boundaries during cloud computing. Well, you could put that data at risk by not being fully aware of the laws surrounding the way that data has to be stored or transmitted in those areas. Put your business at unnecessary risk. So making sure that you go over the legality of that before engaging in cloud operations is pretty important. Similarly, and like you would do on a local computer, is you would want to segregate your sensitive data away from your not so sensitive data. This is actually a really standard security recommendation. When you, for example, say I have a power plant. I store non-confidential information in one location, confidential information in another location, and I have like my employee desktops computers separate from the machines controlling the power grid. And I make sure the machines controlling the power grid and the confidential data are locked down as tight as can be. This means that even if an attacker got access to some of the data, they probably wouldn't be able to access the most sensitive information. It's just another level of protection. You'll never truly be able to stop a really determined attacker or someone with the resources of nation states at their disposal, but you can make it pretty dang hard for an attacker to obtain everything that they might want or the most valuable information. It's like a house break-in in a way. If someone really, really wanted to break into our house, they probably could. But someone less determined might see the locks on the doors and the windows, and an alarm system or a security camera or motion-activated lights in front of the house and decide, not worth it, this is too much effort, I'll be caught, and give up. Dissuading people from performing an activity can be quite powerful in security as well. Another issue, again, that applies to regular computers as well, and regular business operations, are the questions of deletion and virtualization. If you are deleting information on a computer, it doesn't actually totally go away. That's a misconception. It's also why people keep trying to sell software to restore your deleted files. The only way to actually make sure it's gone is to keep writing and wiping the disk over and over and over again. When you're dealing with sensitive data, locally you would have policies to manage this and to make sure that old equipment was disposed of correctly. However, if you're working with a cloud computer, you can't literally drill holes in a hard drive and then throw it in, and then compact it and throw it in a trash can and go over it with a magnet and then finally compact it into a tiny ball and throw it away. You just have to trust that when you deallocate that memory, that it's truly gone and that the cloud provider is scrubbing it appropriately and writing over it and over and over and over again, which, if, for example, you have PII stored there, you don't want anyone else to be able to get it. And this ties in with the virtualization risks. The purpose of virtualization is to create like little mini computers that are not accessible to the main computer, to your main host. When I'm using a virtual machine, I cannot go through that virtual machine to my local hard drive and access those files, at least not with any ease. However, these kinds of leaks in virtualization can and do happen. Technologies change, attacks get more sophisticated, or virtual machine software comes with bugs or is misconfigured. And you, especially, again, dealing with confidential information, you do not want the fact that it could be leaked out or accessed by anyone who's not supposed to. Finally, cloud computing is not recommended for time-sensitive or critical software. Although I went on and on earlier about how there was all this redundancy in cloud computing and it was actually really reliable. There are things like health records where you wouldn't want to take this risk. For example, there was a case where someone died because their medical records because the medical records were hit by a ransomware attack. And they couldn't be accessed in time for this person to receive emergency surgery. That happened in 2020. So, if you're relying on information to save a life and always be available, putting it in a black box, no matter how reliable that black box seems, it may not be your best move. I wouldn't want to take the kinds of chances that would cost someone their life. And one final note. I do think that the cloud needs regulation and standardizations. Not necessarily standardization, but standards. As I mentioned in the section about the Bear Brook case, it doesn't necessarily have to be you that puts the data into the cloud. But if someone puts your data into the cloud, you are the one at risk. And considering that I was given my first Google account at the age of 12, and I wasn't even taught how to log into it properly, I could not possibly have understood the risks I was taking and the privacy policies I was signing, even if I had bothered to try to read them. And ultimately, I would have been the one burned by accepting access to a service I needed for my education. We were required to all have Google Drive accounts, for example. And I feel like it was a bit unfair to have made me make that decision. And it's going to be increasingly harder as the cloud is ever more adaptable and looks more appealing and has more claims to security and resilience than managing your own farm of servers, that you're going to have a harder time being able to stay away from the cloud, whether it's in your personal or work life that cloud computing technology and software are used, or if it's in or if it's with the people you do business with. If your doctor's office, for example, has a private cloud with medical records in it, or say your phone company uses a public cloud to store your account information, you can't escape from the cloud, and no matter how hard you try. And my general assumption and feeling is that it's an unfair risk to put this all on the consumer, the person who will be most hurt by cloud breaches. Anyway, thanks for your time. Thanks for listening to my presentation today. This was really exciting because cloud computing is one of my favorite topics. And I will provide a works cited document along with this PowerPoint. And I highly recommend you look through it.